Hi students, in this lecture we are going to learn about Euler angles. Euler angles, okay. Before that we should know what is the difference between fixed angles and Euler angles rotation. So what is fixed angle rotation and Euler angle rotation is, fixed angles means it will represent the orientation of the object or orientation of the end effector frame or orientation of the any frame which is at joint 1 or joint 2, joint 3, etc. So first, actually there are two types of orientation. One is fixed angle, another one is Euler angle. Okay, so let us discuss first fixed angle. So for that, let us take this frame. Okay, in this is a A frame. So this is x-axis and y-axis and z-axis, and then the other frame, the new frame is B frame. So both are aligned at one point. Okay, so if in this case, if I want to do the fixed angle rotation, means I have to rotate. So now it is the original position. This is the initial position. So initially both the frames are aligned, which means x-axis of both frames A and B and y-axis of both frames A and B and z-axis of both A and B frames are aligned at the origin. So this is the original one. So now I want to give orientation, but that orientation I want to do in fixed angle fashion. Okay, so first let me orientate this uh, B frame x-axis by an angle of alpha. Yeah, you can change the angle, but here yeah, we'll say this gamma, and then y-axis for beta, and then z-axis is alpha. Okay, so in the first case what we do is we keep both the x-axis aligned at one x-axis. We are allowing, with respect to x-axis, we allow the orientation of gamma. Okay, so that is, so but this orientation is with respect to this A frame. Okay, not with the B frame. So here we can say A is a reference frame. Okay, reference frame, and then B is the current frame. Okay, or moving frame. Okay, this is the current frame. So now we orientate the current frame with respect to reference frame, that is called as fixed angles. Whenever you do the orientation with respect to, whenever you do the orientation of the current frame or any moving frame with respect to the reference frame, in then that is called as fixed angle rotation. So here see, with respect to x-axis we have made an angle which is gamma. Then in the next case, your see, there is a displacement of angle, and then with respect to beta, so beta is with respect to y-axis. So here when you rotate, so you have a orientation. So this is with respect to A frame only, with respect to A frame. So here with respect to A frame x-axis, here with respect to A frame y-axis, and then in this case with respect to A frame z-axis. Okay, these are three rotations. So when you rotate the new frame B frame with respect to the reference frame, that is called as fixed angles. And Euler angles is the other way around, like whenever you rotate the current frame with respect to the current frame itself, not with respect to the moving frame itself, not with the standard frame. Okay, so these are the various locations. So this is for fixed angles. Okay, so based on the fixed angles, so you can do the thing, because this is with respect to uh, what reference frame. We have to pre-multiply. So first we did gamma rotation, then we did beta rotation, then we did alpha rotation. So this is pre-multiplication because this is with respect to reference frame. So multiply and then you will get the coordinates. Then if you want to solve, or we can compare with this, so you can compare R11 with this, R12 with this, and we can get the formula, so that you will derive how much is the alpha angle, how much is the beta angle, how much is the gamma angle. Okay, next one is one numerical example. So this is given to you. This is the final orientation or rotation matrix is given to you. So you have to compare with it. So you should know the formula. So already we have derived what is gamma and what is alpha, what is beta. So just substitute it and we can get the angles. Okay, so this is with the fixed angles. The next one is Euler angle rotation. So Euler angle rotation is here, initially both are same. A frame and B frame are aligned, B and A are aligned, these are aligned. But see in this, First you are rotating with respect to z axis, new frame, B frame, and then the next axis you are rotating with respect to B frame. Here also you are rotating with respect to B frame. So this is x-axis rotation, y-axis rotation, here z-axis rotation. Okay, so if you do like this, then this is called as Euler angles, Euler angle rotation, that is with respect to the current frame itself. So start with the frame coincident with the known frame A, rotate B first about ZB. Okay, previously we rotate B about XA. Okay, rotate B with respect to XA. But Euler angle means rotate B with respect to or about ZB by an angle of alpha. Then again, rotate this B frame with about YB. So rotate B about YB, then rotate B about XB by an angle. If you do like this, then this is called as Euler angles. Okay. So how to represent an equation? So what's the first one we did with respect to z-axis? Since it is with respect to current axis, it should be post multiply. So first z-axis, then y-axis, then x-axis. Here also the same thing. Put the rotation matrix values, multiply and get the term, and then that has to be compared with this term r11 normal coordinates, r12, r13, r21, r22, and r23, and r31, r32, and r33. So you can get the values for alpha, beta, gamma. So this is the difference between fixed angle rotation and Euler angle rotation. Okay. So we can, in Euler angles we have different forms. So previously we did z, y, x. This is one Euler angle. Okay. Whereas in another fashion is z, y, z. Okay. So likewise we can have more number of Euler angles, but you have to do the proper orientation. So suppose if I want to write the equation, first one is first thing. So you have to rotate z, okay, along z by an angle of alpha. That is the first one. Then it is post multiply. What is the next one? So rotate the frame B with respect to or about y axis by an angle of beta. Then rotate z by an angle of gamma. Okay, so multiply everything and you can get the answer. So likewise you can do like this. So this is called as Euler angle rotation. Okay, so this is the problem. So you can get this parameter and substitute here and you can get various parameters. Okay, but here we have to use arctan calculator. The reason is here suppose if sine is positive and cos is positive, then the angle is in first quadrant. So then that angle is arctan alpha. Suppose if sine is positive and cos is negative, then angle is in quadrant 2. So in that case you have to subtract. Then if it is in the other third quadrant, then you have to add. So you have to follow this, then only you will get the exact angles. Otherwise uh, you will get infinite solutions for this. Okay, so in this class we have learned fixed angle rotation and Euler angle rotation. Fixed angle is with respect to reference frame, Euler angle is with respect to current frame. So here we did pre multiply and then here we did post multiply. Okay, thanks for watching. That's all for today.